Okay, so in grade 11, we didn't do a whole lot of deriving. I showed you a little bit, but there's definitely more of a focus on that in grade 12. The curriculum actually says that I'm supposed to teach it in certain places. Will I test you on it? They tend to be bonus type of activities on tests. Deriving equations. Okay? But it's a good experience to go through. You're going to see lots of it when you get to university. And so I think that's something you should see here in a sort of a little bit safer environment. Okay, so we're going to derive the kinematics equations. Today is September 11th. 7 years. Oh, enough history, I guess. Okay, so we're going to derive the kinematics equations. So the first thing we're going to do is we're going to look for equation number 1. Now you might remember from grade 11, acceleration is delta v over delta t. Okay? Now I can rearrange that to, I can write that as a equals, delta v means what? Change in velocity. So I'm going to write that as Vf minus Vi all over delta t. Okay, I've just changed delta V into Vf minus Vi. And I'm going to write a little note on the side here. Since the initial velocity, since the initial time often equals 0. Okay? You generally start things with, whenever you start, that's your initial time, and you say that's 0 seconds, right? So since Ti is often equal to 0, okay, delta T just becomes T, okay? We're just going to use the letter T rather than delta T. The delta is sort of, they're nice for a while, but they sort of get a little bit cumbersome sometimes. Yeah, there'll be some profs that are insistent on using delta. That's fine. I'm going to try to simplify things a little for you. Okay? So I'm just going to sort of magically allow the delta to sort of disappear. Okay? And now I'm going to rearrange this formula. I'm going to bring my t up there. And I've got AT equals Vf minus Vi. And I'm going to take the Vi to the other side. And I'm going to have Vi plus AT equals Vf. And generally we like to have the formulas written so that there's one thing on the left and then the rest of the formula on the right? So I'm simply going to do it. I'm just going to switch positions there. And I'm going to write Vf equals Vi plus AT. And that, my friends, is the first kinematics equation. No. That's the first one. Vf equals Vi plus A2. That's equation 1. Okay?
That's one to know.
That's one to know. If it's in a red box like that, you need to know.
So would you just plug this stuff in there?
Yeah.
Oh, sweet.
Yeah, nothing to it. Okay, let's go to equation 2. And be warned, equation 2 and equation 3 are more challenging than equation 1. Okay, so equation 2, and I'm going to write, since the displacement is the area under the VT graph. And given the graph as shown, I'm going to draw a graph right away. Given the graph as shown. Okay, here's my graph. so we are looking at a velocity time graph here, and the displacement is the area under the velocity time graph, okay? And so which area am I talking about? Talking about that area in there, right? What shape is that? An odd rectangle, not an even one? It is a quadrilateral, that's good, Levi. Do you guys know what shape this is called? Trapezoid, right? A trapezoid is defined as a quadrilateral with, no, not two equal sides, because it could be also like this. It simply has one pair of parallel sides. The other sides are not parallel. Okay? Now, if you look carefully, at my little figure here, let me just see if I can do this here. Let me just see if I can do this. Is that a trapezoid? Yes, it is, right? Okay, does anybody know what the formula for the area of a trapezoid is?
Is it long? Because can you just go like area of the rectangle?
You could split into the rectangle and the triangle. Is that what you want to do?
Yeah.
Okay.
It's shorter.
There's a nice easy one, okay? The area of a trapezoid is side 1 plus side 2 divided by 2 times the height. Okay? And the sides are the parallel sides. Okay? This would be side 1, and this would be side 2. And the h in the formula is going to be the height, right there. Okay? That's the height of the trapezoid, right there. That's the h. No, it's not upside down. It's just turned sideways. Okay, so what I'm going to do now is I'm going to rotate this back. Get rid of that. Okay. Get rid of the H, and the S1, and the S2. Now, where were those S1s and S2s? Well, this was S1, and that was S2, and that was H, right? So in this case here, S1 is the initial velocity, isn't it? Right? If this is my initial velocity, actually that black one right there should be, can I grab that, just that one? I'd like to have that. I want to grab that VI. Yeah, I got to ungroup, eh? I got to ungroup that one too. Okay, I want that VI up there because it's got to line up with this right here. Okay, so my side 1 is really my initial velocity. Okay, my side 2 is what? VF. And my H, my height of my trapezoid, is from there to there. Well, what's from there to there? That's T1 to T2, or T2 minus Ti, right? Delta T. And I'll put in brackets here T2 minus T1. Okay? So now, what am I going to do? I'm going to take these values here and I'm going to plug them into this area of a formula, this area of a trapezoid formula. Okay? So my area of my trapezoid becomes side 1 plus side 2. Well, that's going to be VI plus VF divided by 2. Does everyone see what I did? Took this VI and I plugged it in for side 1. Took this VF and I plugged it in for side 2. Divide by 2 times the height, which is delta T. No, we're not even done. Not even close yet. And by the way, this is a D out here, right? Because we're talking about displacement. Okay. I'm going to rewrite this now. Instead of putting divide by 2, I'm going to write 1/2 of VI plus VF.
Can you just say divide by 2?
You could, but there's a reason for this. Okay, I'm going to pull the 1/2 out. A little bit of factoring. Can't do that, Brian? You'll see. Don't ask why, just it is. It's algebra. Okay, now what am I going to do? I'm going to replace the VF in here with, guess what? This one. I'm going to take this VI plus AT, and I'm going to plug that in for VF. Replace VF with equation 1. So it's going to read D equals 1/2 of VI plus, and I'll do this in red for you. What's equation 1? VI plus AT, right? And I'm just going to conveniently forget to put the delta when I put my T down. If you want, but why not do it this way, Brianna? I know what I'm doing. All I did was pull, you don't need the delta.
But it still needs them.
It's still me. It's just to simplify things a little bit, that's all.
So is that plus AT?
Yeah?
Well, since we're saying about that.
But, Brianne, what does equation 1 read? Follow, you got to follow along. You can't just copy what you see.
Are there any other symbols used for plus?
Yeah, that's why it looks so confusing.
I try to make my T's.
But then bracket.
I try to make my T's like that. Yeah. It's VI plus AT. I'm telling you as I say it. You write it how you want. Listen as I go through it. Okay, so now I've got 1/2. Now I get VI plus VI is 2VI. And I'm also going to, I got 2VI. Can I take this T and can I multiply it in? Can I do that? Oh, you wait till the next one. Can I just multiply T in there? So it's going to be 2 times VI times T, not plus, T, plus A times T is going to give me?
Okay, I have a question.
What is your question?
Okay. Why is it VIT and then have T squared?
Because I'm multiplying a T in, right? I've got to multiply the T in here
both of them?
and there. Okay? Now I'm going to move the half back in. 1/2 of 2, 1. So I've simply got VIT plus, pardon me?
Yeah, it's supposed to make it
Plus 1/2 AT squared. And that is kinematics equation number 2. Now, do you need to go through all that every time you want to use this formula? No. You simply need to have a general appreciation of for where this formula comes from.
Would you say that's easier than just finding the area of the rectangle and the triangle and then adding them together?
Yeah. Would you say that this is easier?
Yeah.
If you've got the graph, no. But if you've only got a word problem that gives you initial velocity, time, and acceleration, you'd have to make the graph, right? Then you'd have to, trust me, you guys, once you start doing word problems with these, you'll find that it's a lot easier. Hurry up. Okay? Now, Hopefully your brains are sufficiently warmed up for equation number 3.
Probably not, but
I thought that was like an actual problem.
No. We're just deriving equations here. I'm showing you where these equations come from. That's all we're doing. Okay? Equation number 3. I hope you guys like fractions. Oh.
There was a guy that came up with these equations.
Probably Newton, I'm thinking. I don't know. Take equation 1, and I want you to isolate t. Equation 1, and isolate t. Vf equals Vi plus At, right? Isolate t means write it as t equals. So that's going to be Vf minus Vi equals At. And then I'm going to divide by A. Okay, I've now isolated T. Okay, we isolate T, and now I'm going to put this into equation number 2. Oh, I love this part. What was equation 2? D equals VIT plus 1/2 AT squared. I'm going to take this value for T, and I'm going to put it in here for T. Doesn't that look like fun? And here's what it looks like. D equals VI times T, which is VF minus VI all over A. Plus 1/2 A times T squared. And T is VF minus VI all over A squared. Will these A's cancel? Is that what you're asking? Sure they would. No. Because you have 2 A's, right? You get A squared.
So what are these defined again?
We're coming up with another formula for kinematics. We're deriving an equation. We're
What does it find for you, like when you what situation, like when you're going for a traffic light, what?
No. When we get to the word problems examples, you'll understand. Don't worry. I'll take you to the right place.
So the normal formula is
No, some of the formulas that you have won't work. Yeah. Okay. I hope your algebra skills are up to par. That's not a good sign. I'm going to multiply in the VI. So I'm going to have here, and I have to be very careful how I write this, right? VI VF minus VI squared. I'm multiplying in here, right? And that's going to be all over A. All I did was do what? VI times VF is?
Oh, we got it. I keep forgetting that part. Okay, keep going.
Okay, now I'm going to write this 1/2 times A. I'm just going to write that as A over 2. Is that okay? 1/2 times A, write that as A over 2. Do you remember your FOIL? I got to go VF minus VI squared. Remember FOIL? First outside, inside last? Binomial expansion? You have taken math, have you not?
Yes, we are. No, my class never did.
Come on. You never took something like x plus 3 and multiplied by x minus 2 and went x squared plus 3x minus 2x minus 6. Binomial times a binomial. FOIL. Firsts, outsides, insides, lasts.
No, Mr. H told us to never remember that we did that ever.
What? I'm going to see Mr. Ray at break, and I'm going to ask him.
And I never ever learned that either.
Well, just because you didn't learn it doesn't mean that you weren't taught it.
No, never.
Oh, really?
Yeah, and I never learned it. It was in grade 11.
Pardon me? Really?
And in grade 11 he said don't do foil.
Oh.
And I never learned it, so I just didn't.
Okay, well, I hope, because I'm going to need it right now. So we're going to foil this out here. So I got to go, what's this going to be? Okay, you guys apparently know what it is. They've done it in French, I guess. So what's it going to be, Ben? If I multiply VF minus VI squared. Don't remember?
Say it in French.
VF minus VI squared. I'll start you off. VI squared.
This is VF, not VI.
Yeah, it's VF.
You just said
First, oh, did I say VI? VF squared. You guys don't know how to do this? Minus 2 VI VF plus VI squared. You do, Julian? So Mr. Ray did teach it?
No, but actually he did tell us
Mr. Smalling. So
All over A squared. I'm pretty sure every math teacher knows how to foil.
they never taught me.
Who was your math teacher, Ben? Mr. Ray?
Okay, grade 9 it was a multiplier, and then Dory.
Anyways, that's what it is. You should know how to do that. At a university, they're going to expect you to be able to do foil like that, like that, like no even, no question about it. VF squared minus 2 VI VF plus VI squared all over A squared. Okay. No? I don't really want to have to teach you foil, because we'll be here all day.
Is it hard?
No, it's, no. Okay, I'm going to teach you foil. All right, we'll continue now. Now over here, I'm not going to do anything. I'm just going to rewrite this part because I'm not ready yet to do anything over here. So I'll just rewrite the left-hand side. Okay? Now here's where we're going to cancel our a's, Julie. I got an a up top and I got an a squared, right? So I can get rid of that one and I can get rid of the squared, right? And I'm going to write this now as plus VF squared. I'm going to rewrite the top minus 2VI VF plus VI squared. And that's all going to be over 2A. So I've got something over A plus something over 2A. How do you add fractions? You have to go to a common denominator, don't you? You go to a common denominator. This would be like adding something over 3 and something over 2 times 3, like 6, right? So you'd have to put it all over 6, right? So what I really need to do is put it all over 2A. How am I going to put this over 2A? Multiply top and bottom by 2, right? Multiply top and bottom by 2. So there's the bottom times 2. When I multiply the top by 2, I'm going to have 2. Oops. Ooh, that's a big one. 2 VI VF minus 2 VI squared plus all of that again. VF squared minus 2 VI VF plus VI squared all over 2A. We're getting close. We're getting close. Because what's going to happen here all of a sudden? It's all going to combine. It's all going to fall out nice. Very nice. Okay, so it's all over 2A, right? Okay. Now I'm going to put my VF squared first, okay? VF squared. I got plus 2 VIVF, and I got minus 2 VIVF. See you later. Minus 2 VI squared plus VI squared. Minus VI squared. Now, doesn't that look nice? Oh, and by the way, this is all equal to D, right? We had D right at the start there. right? We're talking about the displacement here.
Is that the final one?
Almost. Almost. You could write it like that if you want. We tend to write it like this. We're going to move the 2a up there. 2ad equals vf squared minus vi squared. Take the vi to the other side, and you're left with vf squared equals vi squared plus 2ad.
And that's the,
I'm putting it in a red box. Vf squared equals vi squared plus 2ad. 2a times d. 2 times a times d, right?
How do you even come up with these numbers?
I just showed you.
Yeah, whoever how does somebody just, oh, I'm gonna do this already.
and I can make up formulas if I wanted to.
You could, but you'd have to follow the rules of algebra and mathematics.
T equals 47, yeah. And it works.
Oh, it does. Good for you. Good for you. Okay. Those are the 3 kinematics equations that you're going to use in grade 12.
Yeah, it's all we need to know.
Nope. One last thing that you're going to love.
Gee, that's, wonder how long you've been doing that.
Remember.
Probably 3 seconds before this movie.
Do you remember the quadratic formula?
Yeah, I took that.
X equals negative b plus or minus square root of remember that? You're going to need that one too. Okay? I would urge you to make sure that your cheat sheet has those formulas written correctly. Don't miss up a VI and a VF or anything like that. It's a long derivation, yes. There's more in your future in the next 5 months.
How did they come up with that formula?
Let's not find
Favorite
out.
numbers and letters.
Favorite numbers and letters.
I like that.
I could derive it if you want.
Is it
No,
long?
let's not.
Let's go for it.
No, why would you say such a thing?
Never.
Now, when you were first taught it, though, was it just, here it is?
Yeah. Remember the last
You were told where it came from?